Now let's discuss example number 2. Example number 2 is a standard forward reverse circuit. Okay, just like in a motor, for example, it can perform the forward operation or it can also perform reverse operation. Okay, now it says here each direction's coil has its own start button. In other words, the forward operation has its own start button and the reverse operation has also its own start button. The single button stops either coil's operation. So in both forward and reverse operation, there will only be one single stop button. In this circuit, you must push the stop before changing direction. So if for example, the current condition of your motor is forward, if you want it do the reverse operation, then you have to push first the stop button before changing direction to reverse operation. Interlocks are provided so that both outputs cannot be energized at the same time. So in other words, the interlocks here are provided in order to provide the uh, the output of both forward and reverse to be energized, no? So dili man siya pwedeng naka-forward ka at the same time naka-reverse ka. So kung motor na siya, possibility ang imong motor masunog yun siya, no? So that's our problem. Now, the problem is interpreted using this circuit here. So we have the forward circuit and we have also the reverse circuit. Now, based on our problem, each circuit has its own start button. In this case, for the forward, it is represented by input 002, and for the reverse, it is represented by input 003. And it has only one or single stop button. In this case, it is represented by input 001, and in the reverse, also input 001. Since they have the same number, input 001, that means that it is only one button or only one switch, no, which is the stop button. Now, you have here in your reverse button CR017, which is the internal contact of your CR017 output. We call this one here as your interlock. I mean your seal. And at the same time, you also have here 018, which is actually, again, the internal contact of your CR018 output. And we call this as your seal circuit. Now, this one here is also the internal contact of CR018, which is normally closed. And we call this the interlock. Okay? And then, for CR17, there is also another internal contact here, which is normally closed contact, and this is again an interlock for your reverse operation. Okay, so this is how your circuit operates. If you push the start button, this will close. That is input 002. That is the start button of your forward circuit. Again, the normally open contact will close, and so that your current will now flow from left going to the right, energizing your CR017. When CR017 here is energized, automatically your seal here, which is CR017, will be closed. And even if you remove the start button here, no, it goes back to the normally open condition, the current will still be flowing from left going to the right. So your CR017 here will still be energized. Now, since CR017 here, the forward action is energized, your CR017 here, which is your interlock, will open. Okay, this is normally closed, and this will open when CR017 here is energized. Now, if this is open here, the internal contact of your CR017 or the interlock, I mean, even if you accidentally push input 003, which is the reverse start, your CR018 will not energize because your CR17 here is open. So that will prevent, again, the energizing of both outputs, which is the forward and the reverse output. Now, if you want to do the reverse operation, all you have to do, based on the problem, all you have to do is to push the stop button, and then the forward operation will be de-energized, no? Because no current can pass from left going to the right because input 001 here will be open. Okay? So if this is open, both CR017 and CR018 will be de-energized. So that's the time that you push your reverse start button, which is input 003. That is after releasing your stop button, input 001. When you release it, automatically it will go back to its normally closed condition. Then you start to push input 003. This will close here. Then automatically current will now flow from left going to the right, energizing your output CR018, and thus causing a sealed contact here, or sealed circuit. That means that the contact is closed, so current will still be flowing from left going to the right, even if you release the start button. When you release the start button, of course, your closed contact here will go back to open condition. Okay? So, since CR018 here is energized, automatically the CR018 here will be open. So that even if you accidentally push input 002 here, your CR017 will not energize. Okay? Only one output will be energized, in this case, the reverse output condition. So, that's how the operation works. If you want to go back to forward condition or forward operation, then all you have to do again is to push the stop button, and the operation of the reverse will be stopped. The CR018 will be de-energized, and then you release the stop button and press input 002 to start again the forward operation. Okay? So in the right side of your monitor is the Siemens equivalent of the circuit that we have discussed. So, in the Siemens, you have to specify your forward circuit in network 1, and the reverse circuit which should be placed in network 2. Okay? So again, the input 001 for the forward circuit is represented by I 0.1. The inputs are represented by I, and the outputs are represented by Q. So for the start button of your forward, it is represented by I 0.2, and for the start button of your reverse, it will have to be represented by I 0.3. Your output for forward operation is represented by Q 0.0. The internal contacts here will also be Q 0.0, which represents the seal, and there the other internal contact here will also be represented by Q 0.0, which is your interlock. This one here is your interlock. And for the reverse, again, your reverse start button is represented by I 0.3. Your output is represented by Q 0.1. The internal contact here, which is your seal, will also be represented by Q 0.1. And then the interlock here on the forward circuit will be represented again by Q 0.1. Again, the interlocks here will prevent to energize both the forward and the reverse output.